Alright, ladies and gents, we are solving multi-step equations today by completing a foldable that you've cut the bottom off of from the dotted line and folded it over so that it looks like mine. Beautiful. If you open to example number 1, we are going to solve the problem 4x plus 3 is equal to 15. Very similar to one-step equations. We're going to put a line down our equal sign. And I'm trying to get my x, my variable, all by itself. So the first thing I want to move is the item not by my x, which is this plus 3. The opposite of adding 3 is subtracting 3. If I do it to one side of my equal sign, I have to do it to the other side of my equal sign. Positive 3 minus 3 cancels out. I bring my 4x down. 15 minus 3 is 12. Now what's different from yesterday than today is I still have 4 x's here and not just one x. So I need to take it a step further and get my x completely alone by dividing by 4. Same thing, if I do it to one side of my equal sign, I have to do it to the other side of my equal sign. 4 divided by 4 is 1, so x is all alone now. 12 divided by 4 is 3, so my answer x is equal to 3. I can always go back and check my work to make sure it's right by plugging it back into my equation. So my original equation was 4x plus 3 is equal to 15. So if I plug this 3 in, 4 times 3 plus 3, does that equal 15? Well, 4 times 3, 12. 12 plus 3, oh, it is 15. So we did it right, we checked our work, and we're good to go. I say that a lot in videos, but whatever. It works. Next one. Same thing. Split my equal sign. I need to get my x completely by itself, so the first thing I'm going to do is move this 10, since it's next to my x. If I do it on one side, I have to do it on the other. Cancels out. I have negative 5x. Negative 5x is equal to 65. I still have a negative 5 next to my x, so I want to go a step further. Divide, since it's being multiplied right here, got to do the opposite. If I divide on one side, I have to divide on the other side. Cancels out. X is alone. 65 divided by negative 5 is a negative 13. And I got my answer. So that's our first two examples for today. We're going to go ahead and close that section of our foldable. And we're going to go to the next one, which has some fractions in it. So our first problem we're going to do is x over 4, which remember that's just division, minus 3 is equal to 7. So again, start very similar. Put your line down your equal sign. Trying to get my x all alone. So the first thing I want to move is this 3. The opposite of subtracting 3 is adding 3. If I do it to one side, I got to do it to the other. This right here cancels out. This didn't change at all, so I bring down my x divided by 4. And 7 plus 3 is 10. Since x is being divided by 4, it's not completely by itself yet. So the opposite of dividing by 4 is multiplying by 4. If I multiply by 4 on one side, I have to multiply by 4 on the other side. Cancels out over here. X is all alone. 10 times 4 is 40. Circle my answer. And I did that one perfectly. Continuing on. X divided by negative 3 plus 9 is equal to negative 4. I follow my same steps first. Put a line down my equal sign. Trying to get x all alone. Since this is completely separate from my x, I'm going to move that plus 9. The opposite of adding 9 is subtracting 9. If I do it on one side of my equal sign, I have to do it on the other. This one cancels out. Didn't do anything down here yet, so I'm just going to move x divided by negative 3 over. Negative 4 divided by negative 9 is not divided. Negative 4 plus negative 9, sorry about that, is equal to negative 13. Since x isn't completely alone yet, we've got to do one more step. X currently is being divided by negative 3, so I need to multiply. That's the opposite of division. Got to multiply by negative 3. Cancels out. X is alone. Negative 13 times negative 3 is a positive 39. And then I circle my answer. So that's what we do when they look like a fraction. Remember, those fractions are just kind of fancy division signs. The last section that we're going to look through together are these ones down at the bottom, where it's x plus 3. All of that's being divided by 4, and then it's equal to 7. Oh, oops, we're stuck together. So again, put my line down my equal sign, and I'm trying to get my x all alone. If I'm trying to get x all alone, I got to do what's being done to all this right here, which is being divided by 4. The opposite, or the inverse, of dividing by 4 is multiplying by 4. Don't forget, if you do it on one side of your equation, you have to do it on the other side of your equation as well. Cancels out over here. You're going to do x plus 3 is equal to 7 times 4 is 28. Now that you got that, you have one step left. Since you have x plus 3, the inverse of adding 3 is subtracting 3. You do it on one side of your equation, you have to do it on the other side of your equation. Then we got 28 minus 3, and you have 25. Be careful when you start problems that look like this. They look very similar to the one above it. But since this whole thing is being divided by 4, that's why our first step had to be to multiply by 4. Where up at the one above it, only my x was being divided by 4, so that's why it looks a little bit different. So make sure we're being careful with our work on there. And then our last problem together is this x minus 2 divided by negative 7. All of that is equal to 3. So again, put your line down your equal sign. Trying to get my x all by itself. Since the whole thing, x minus 2, is all being divided by negative 7, we need to do the inverse first, which is multiplying by negative 7. We do it on one side of our equation. We're going to do it on the other side of our equation. So we get x minus 2 is equal to negative 21. We're almost finished. The last step to get x by itself is the inverse of subtracting 2. The inverse of subtracting is adding. Negative 21 plus 2 is negative 19. And that is our answer. Don't forget, we can always go back and plug any of these in to our original equations to check to make sure that they are correct. But you have just completed your foldable on solving multi-step equations.